Keep the camera on. Keep the cameras running.
Now I'm so vulnerable.
Oh, shit.
I didn't know I'd be on camera today.
Oh, come on, Adam. You went to college for this.
I wonder if people would call me inorganic.
No, that's inauthentic.
Put me in.
Welcome back to another episode of Atoms and Bonds. My name is Adam Rosenzweig, and this is the show where I, a real-life scientist, do a chemistry experiment with the help of a fabulous lab partner. Today, I am joined by the frigid bitch herself, Blair Bitch. How you doing?
I'm good. It's getting chilly outside, so this
chilly.
feels like the perfect time to do such an experiment. Spoiler alert.
Tell us a little bit about you. Who are you? What do you do?
I'm just another gorgeous slut trying to make it in the big city. I'm the Barbie that you haunted as a child, that you tortured, and I'm back to haunt you.
Happy Halloween. Tell me, what is your background with chemistry, science in general? Where are you coming from?
Well, don't ask my high school teachers because they will give me scathing reviews. I always enjoyed hands-on things, so experiments and like anything that I could see with my eyes, anything I could touch or feel or experience versus things on the page.
Oh, we're in the wet lab today, so we're gonna get our hands on some stuff.
The lab is wet.
All right, Blair. So, like you said, it's getting a little chilly outside. So today we're going to be playing with endothermic reactions. So when you think of the most like stereotypical comic book version of chemistry, what are you thinking of?
Beakers. I want to say meniscus. Atoms and bonds.
Whoa.
Things that go boom, yeah.
But not everything goes boom in chemistry. So some reactions, instead of mixing things together and putting out a lot of heat, some reactions pull energy from the outside environment and they use that energy to make themselves go. And
Stop talking about me.
And so they end up being cold. And that's called an endothermic reaction. Endo meaning in, thermo, heat goes in.
Like that.
So that's what we're going to be doing today. We're going to be doing a couple demonstrations of endothermic reactions. And we can just get right into it. So let's get into a little PPE. Oh, like we're rolling?
Yeah.
Okay, cool. All right, so now that we are properly protected, we can introduce our reagents today that we're going to be playing with. We don't have too many, but let's just go right down the line. Begin with this little lady right here.
Sodium bicarbonate.
Hell yeah. Some 10% acetic acid. She'll be playing the role of vinegar today.
We've got ammonium chloride.
Yeah.
Is that what goes in a pool?
And last we have barium hydroxide. Ooh. As I said, we're playing with endothermic reactions today, so things you mix them together and they get cold. We're gonna start with a little at-home version that everybody should be familiar with. We're gonna do a little baking soda and vinegar. If you've never done it before and you've never felt it, when you mix them together and it goes all bubble, what's left actually feels kind of cold. Into this little flask here, I'm gonna dump some of our sodium bicarb, aka baking soda. Bicarb in the flask. Will you do the honors of dumping a little bit of our 10% acetic acid, which is approximately what your vinegar at home is.
10%? Am I balling?
Oh my god! We did science. Okay, if we swirl it, okay, give her a feel on the bottom.
Oh.
It's a little chilly.
It is a little chilly.
Yeah, so you can do this one at home. So when bonds are formed, bonds are very stable, so energy is released. But to break a bond, you need to put energy in to pull the atoms apart so that they can go and do their own thing. And so depending on the kind of rearrangements that's happening in any given reaction, you might be letting off more energy than you're taking in, or you might be taking in more energy than you're letting off. And where is that energy coming from? It's coming from the environment. We're surrounded by energy all the time. We have heat, we have light. And so what these endothermic reactions are doing is they're pulling in heat energy from the environment, and that's what gives the sensation of coldness.
Okay,
Yeah.
I'm getting like black isn't a color, it's the absence of color
Very
kind
bad.
of situation.
Exactly.
Yeah.
No, like actually exactly. Like cold is not cold, it's just the absence of heat.
Spinning metaphors, analogies, whatever.
So now we can move on to our big boy reaction. Is a reaction that I like very much. It's very fun. So we're going to mix together our ammonium chloride. This is our ammonium chloride. Woo. This is our barium hydroxide. Love. So you're going to mix them together in this beaker. And so a couple very cool things are going to happen. So we have two solids, and you're going to just start mixing them. And after about like 20 seconds or so, it's going to start to liquefy. So we're starting with two solids. It's going to turn into a liquid, and it's also going to get really, really cold. But before we do any of that, I'm going to put a couple drops of water onto this wooden block.
H2O.
Are you taking notes? And what's going to happen is that this reaction is going to get so cold that it's going to freeze the water beneath it. And then we should be able to lift the board. Light as a feather, stiff as a board.
Ah! Spooky, spooky!
Spooky, spooky. What is our thermometer telling us right now? She's about like
22.
Yeah, like 22 ambient room temperature in here. And we'll use this guy to see just how frosty we can get. So I'm gonna first go in with our barium hydroxide. You can do the honors of pouring in the ammonium chloride.
Okay. All of it?
Yep, all of it. And then if you could take our little silly straw
and mix.
And just start stirring.
It's getting a little, I don't want to say gummy, but gummy.
Okay. And if
yeah.
you take your little finger and touch the side of the beaker.
It's cold.
She's cold.
It's cold.
So first, let's see what we got temperature-wise. Oh, she's plummeting.
Oh. Dropping it like it's not hot.
Yeah, we're like minus 10 degrees.
10. Yeah.
So this is an incredibly endothermic reaction. So we have, it's liquidy, it's chilly, and it's so chilly.
It worked!
So it got so cold that it froze the water underneath the beaker, and now we are causing magic.
You raise me up!
Oh, endothermic reactions. They're wild.
Endothermic happened on the inside to make me happy on the outside.
Yeah.
And the inside. I'm happy all over.
Get into it. Like, I mean, come on. Come on. That's pretty cool. How was it for you?
I'm fascinated, and I really want to touch it. But
You can touch it. You touch the side.
oh wow,
Yeah, it's like really cold.
wild.
Blair, thank you so much for joining us on this episode.
Thank you for having me.
Oh, please. My pleasure. Anytime. Where can we find you out in the world? Where can we find you out on the internets?
Well, I live under the Queensboro Bridge, and if you, like, bark when you're going over it, I should hear you, and I usually respond to that.
Right.
You can find me online at BlairBitchNYC on Instagram, Twitter, Venmo under the business tab, because there's never a wrong time to tip a drag queen.
Yeah, right now when you're watching this video, it's a great time to go tip her.
Blair Bitch
Hello.
NYC. Keep an eye on me. Keep both of them on me.
Excellent.
Yeah.
Well, thank you again so much for being here. Thank you for watching Atoms and Bonds, and we'll see you next time with another amazing experiment. Bye.
Bye.
Hi, thanks for watching Atoms and Bonds. For more episodes, subscribe to our YouTube channel, and don't forget to follow us on socials at Atoms and Bonds. Thanks for watching. Bye.